The next question is, for a given chemical reaction, gamma 1A plus gamma 2B gives gamma 3C plus gamma 4D. Concentration of C changes from 10 millimoles per decimeter cube to 20 millimoles per decimeter cube in 10 seconds. Rate of appearance of D is 1.5 times the rate of disappearance of B, which is twice the rate of disappearance of A. The rate of appearance of D has been experimentally determined to be 9 millimoles per decimeter cube per second. Therefore, the rate of the reaction is. So, in this question, they are asking us to find the rate of the reaction. You may think that already the rate is given, no? Already the rate of appearance of D is given. Also, the change in concentration of C is also given. Then, what we have to find in this question? So, you may think in that way. So, you see this equation. In this equation, coefficient is not mentioned. Instead of that, gamma 1, gamma 2, gamma 3 and gamma 4 is mentioned. So, how will you find the rate of the reaction? So, the given equation is gamma 1A plus gamma 2B gives gamma 3C plus gamma 4D. So, we can write the rate of the equation. Rate of the reaction is, for the reactant, it should be negative. So, minus 1 divided by the coefficient. So, always the rate of the reaction, in that the coefficient is also included. So, 1 divided by gamma 1 into change in concentration of A by change in time, which is equal to minus 1 by gamma 2 change in concentration of B divided by change in time, which is equal to, then now we are going to the products. For products, it is positive. So, 1 by gamma 3 change in concentration of C by change in time, which is equal to plus 1 by gamma 4 change in concentration of D by change in time. So, in this question, the rate of appearance of D is given. So, the rate of appearance of D is 9 millimoles per decimeter cube. So, how we can write that? So, the rate of change of concentration of D with respect to time is mentioned as 9 millimoles per decimeter cube per second inverse. But still, to find the rate of the reaction, you need to know the coefficient. You have to know gamma 4. So, 1 by gamma 4 into rate of appearance of D will give you the rate of the reaction. So, this 9 should be divided by some number gamma 4. In same way, the concentration change is also given for C. So, with respect to C, how we can write the rate of the reaction? So, the rate of the reaction is equal to 1 by gamma 3 change in concentration of C by change in time. So, 1 by gamma 3, what is the change in concentration? So, the change in concentration is final concentration minus the initial concentration divided by time. So, what is the final concentration? 20. Initial concentration is 10 and time is 10 seconds. So, we will write that. So, the final concentration is 20 minus initial concentration 10 divided by 10. So, this is equal to 1 by gamma 3 10 divided by 10, which is equal to 1 by gamma 3 into 1, and the unit is millimoles per decimeter cube per second. So, here also you need to know the coefficient gamma 3. So, first you have to find all the coefficients of this equation. For that only the information is given. So, it is given from the second line. Rate of appearance of D is 1.5 times the rate of disappearance of B, which is twice the rate of disappearance of A. So, with this line we can find the coefficients. So, we will continue in the next page. First, what is given? Rate of appearance of D is 1.5 times the rate of disappearance of B. We will write that. So, what is rate of appearance of D? Change in concentration of D by change in time. This is equal to 1.5 times rate of disappearance of D. So, change in concentration of B by change in time. Here we are talking about disappearance. So, you have to indicate with negative sign. This 1.5 we can also write as 3 divided by 2. So, 1.5 now we are going to write as 3 by 2. So, now you take this 3 to the left hand side. So, 1 by 3 change in concentration of D by change in time is equal to minus 1 by 2 change in concentration of B by change in time. Now, we will see the next line. The rate of disappearance of B. which is twice the rate of disappearance of A. So the rate of disappearance of B minus rate of disappearance of B is equal to twice, 2 times rate of disappearance of A. So we are talking about disappearance. So here also you have to include negative sign. So now also we are going to take this 2 to the left hand side. So minus 1 by 2 change in concentration of B by change in time is equal to minus change in concentration of A by change in time. Already we are having this minus 1 by 2 rate of change of B in this term, no? So we can equate this equation to another term as minus change in concentration of A by change in time. So we are having this equation here. We are just combining all the 3 terms. So we got this minus 1 by 2 change in concentration of B by change in time is equal to rate of disappearance of A. So just we wrote all the 3 terms together. Now we got that change in concentration of C by change in time as 1 millimoles per decimeter cube per second inverse. Then we got change in concentration of D by change in time as 9 millimoles per decimeter cube per second inverse. We already saw that. So change in D is 9 moles decimeter cube second inverse. Change in C is 1 millimoles decimeter cube second inverse. So how these two are related? How we can write the change in concentration of C with respect to time in relation with D? So we can just divide that by 9. So when you divide this by 9, you are going to get 1. So 1 by 9 of the rate of appearance of D. So this is how these two terms are related. Now this 9 we can write as 3 into 3. So let us just take one of the 3 to the left hand side. So what we will get? 3 into the rate of appearance of C is equal to 1 by 3 of rate of appearance of D. But already we are having this rate of appearance of D, no? In this equation itself, we are having this rate of appearance of D. So in this equation, I can also include another term. So the another term is this rate of appearance of C. So here itself, we can write this whole equation is equal to, so I'll erase this. This is equal to 3 into rate of appearance of C. So in this equation, we are having all the 4 terms of the equation. So now we will form the equation from this rate of the reaction. So we will continue in the next page. So first we will write this equation in the next page and we are going to find the coefficient. So we have written the equation. Now let us write from the reactants. So the first reactant is, so the equation is A plus B gives C plus D. So first we are going to write the rate of the reaction from the reactants. So the first reactant is A. So the disappearance of A is, we are having this term. So minus the disappearance of A is equal to, then we are having B. So for B we are having minus 1 by 2 into disappearance of B is equal to, then we are having the product C. So for product C we are having this term 3 into the rate of appearance of C, which is equal to, then the last is D. For D we are having 1 by 3 the rate of appearance of D. So we already saw for the equation, when there is a coefficient, the coefficient is written like this. In the rate of the reaction, it is written as 1 by the coefficient. So here also we are having such terms. So we have to write the coefficient from the rate of the reaction. So the equation is A plus B gives C plus D. So for A we don't have any coefficient. So the coefficient is 1. For B we are having 1 by 2. So you have to write as 2. Then for C we are having 3 in numerator. So how we have to write the coefficient? It is 1 by 3. Then for D it is 1 by 3. So the coefficient is just 3. So here we are having 1 by 3 C. So we can just multiply this whole equation into 3. So we can cancel this 3. So 3A plus 6B gives 1C plus 9D. So this is same as the equation given in question. Gamma 1A plus gamma 2B gives gamma 3C plus gamma 4D. So we got the values of gamma 3 as 1 and gamma 4 as 9. So with this we can find the rate of the reaction. So already we saw that the rate with respect to D is 9 divided by gamma 4. So we got gamma 4 value as 9. So it is 9 divided by 9, which is equal to 1. And the unit is millimoles per decimeter cube per second inverse. And 1 divided by gamma 3. The value of gamma 3 is 1. So 1 divided by 1, which gives 1 only. And the unit is millimoles per decimeter cube per second inverse. So anyway, the rate is the same. So the rate of the reaction is 1 millimole per decimeter cube per second inverse. I hope you understand this question. The reaction that occurs in a breath analyzer, a device used to determine the alcohol level in a person's bloodstream is. So our equation is given. If the appearance of 2Cr2SO4 tries is 2.67 moles per minute at a particular time, the rate of disappearance of C2H6O at the same time is. So in this equation, we are talking about two compounds. One is the reactant C2H6O. So we are talking about the disappearance of the reactant C2H6O, and then we are talking about the compound Cr2SO4 tries. So we are talking about the appearance of Cr2SO4 tries. So with respect to the appearance and disappearance of these two compounds, we are going to determine the rate of the reaction. So rate of the reaction for the reactant C2H6O. So for a reactant it is negative. So minus, and the coefficient of the reactant. The coefficient of this reactant is 3. So minus 1 by 3 change in concentration of the reactant C2H6O with respect to time. So this is equal to, with respect to the product, so it is positive only, and the coefficient is 2. So 1 by 2 change in concentration of Cr2SO4 tries with respect to time. So in this question, they are asking us to find the rate of change of concentration of C2H6O with respect to time. So in question, the value of change in concentration of Cr2SO4 tries is given as 2.67. So we need to find this term. So this we have to find the change in concentration of C2H6O with respect to time. So take this 3 to the right hand side. So if we take this 3 to the right hand side, then the left hand side is change in concentration of C2H6O divided by dt. Then here we are having the negative sign. So this tells the rate of disappearance of C2H65, which we have to find in this question. So this is equal to 3 will go to the numerator. So 3 by 2 into the value of this term is given in question itself. So it is 2.67. So this is nothing but 1.5 into 2.67. So if you multiply this, you will get the answer 4.005 moles per minute. So the nearest integer is 4 moles per minute inverse. The next question is, the following data was obtained for chemical reaction given below at 975 Kelvin. 2NO plus 2H2 gives N2 plus 2H2O. So the data is given in this table. The order of the reaction with respect to NO is. So for the given reaction, we can write the rate law. Rate is equal to rate constant into concentration of NO power X. We don't know the order of the reaction with respect to NO. So it is X. Then concentration of H2 power Y. In this question, we are asked to find only X. So this concentration of H2 should be same. It should be constant value. So in this given table, the row A and B, if we compare these two rows, concentration of H2 is same in these two rows. So we can use this row A and B. So we will write the rate of the reaction using that first row. So in the first row, so we have written the rate of the reaction is equal to rate constant into concentration of NO power X, concentration of H2 power Y. So in the first row, the rate of the reaction is mentioned as 7 into 10 power minus 9 and it is equal to rate constant into concentration of NO is mentioned as 8 into 10 power minus 5. So we will substitute that value here. So it is 8 into 10 power minus 5 whole power X, and concentration of H2 is mentioned as 8 into 10 power minus 5 whole power Y. So this is the first equation. Now if you go to the second row, the rate of the reaction is mentioned as 2.1 into 10 power minus 8, which is equal to rate constant into concentration of NO is given as 24 into 10 power minus 5 whole power X. Then concentration of H2 is again 8 into 10 power minus 5 whole power Y. So this is the second equation. Now we are going to divide the second equation by the first equation. So the rate constant will get cancelled and concentration of H2 will also get cancelled. So the left hand side is, I will write it here, the left hand side is 2.1 into 10 power minus 8 divided by 7 into 10 power minus 9, which is equal to 24 into 10 power minus 5 divided by 8 into 10 power minus 5 whole power X. So if we solve this 10 power minus 5 will get cancelled, and then here you will get 0.3. 2.1 by 7 is 0.3, and if you cancel the power, so you will get into 10 power minus 8 divided by 10 power minus 9. So it is 10 power minus 8 into 10 power 9. When it goes to the numerator, it will become 10 power plus 9. So you will get a 10. So that is equal to 24 by 8 is 3 whole power X. So 0.3 into 10 is 3. So 3 equal to 3 power X. So I will continue here. We are getting 3 equal to 3 power X. So the base is same. So the power should be equated. So here you are having 3 power 1. So the X value is nothing but 1. So it tells that the order of the reaction with respect to NO is 1. So it is first order reaction. So it is first order with respect to NO. The next question is, the inactivation rate of a viral preparation is proportional to the amount of virus in the first minute after preparation. So here they are telling the time T is equal to 1 minute. So in the first minute after preparation, 10% of the virus is inactivated. So they are telling after the first minute 10% is inactivated. So what will be the remaining? We have to find that. So let us assume the initial amount of the virus is 100 units. So after 1 minute, 10% of the virus is inactivated. So what is the remaining? So initial minus 10% of initial. So the initial amount is 100. So 100 minus 10% of 100. So 100 minus 10% is 10 by 100 into 100. So 100 will get cancelled. So the answer is 100 minus 10 is equal to 90 units. In this question, they are telling us to find the rate constant for the viral inactivation is dash into 10 power minus 3 minute inverse. So the unit of rate constant K is given as minute inverse. So we know that only for first order kinetics, the unit of the rate constant will be time inverse. That is either it will be second inverse or minute inverse. So only for first order kinetics, the unit will be minute inverse. So this whole reaction is a first order reaction. So we have to keep that in mind. So in this question, we have to find the rate constant for this reaction. So we can use the integrated rate law for the first order kinetics. Rate constant is equal to 2.303 divided by time into log of initial concentration of the reactant divided by concentration of reactant at time t. So rate constant is equal to 2.303 divided by time t is 1 minute. So divided by 1 into log of, so the initial concentration of the reactant is taken as 100 and the concentration after 1 minute is taken as 90. So we have to substitute that. So log of 100 divided by 90. So the 0 we can cancel. So K is equal to 2.303 into, so here we are having log of 10 by 9. We can write that as log of 10 minus log of 9. So how can we write this log 9? Log 9 is nothing but log of 3 square. And in question itself it is mentioned log of x power y is equal to y log x. So log of 3 power 2 is equal to 2 log 3. So in place of log 9 we can substitute this value. So rate constant is equal to 2.303. Log of 10 is 1. Log 10 value is 1 minus 2 into log 3. K is equal to 2.303. 1 minus 2 into log 3 value is given in question itself, 0.477. So the rate constant is equal to 2.303. 1 minus 2 into this number, 2 into 0.477 is 0.954. Then you have to subtract this number from 1. So 1 minus 0.954 is 0.046. Then the final answer 2.303 into 0.046 is 0.1059 minute inverse. So in this question the answer is rate constant is equal to 0.1059 minute inverse, but the answer should be in 10 power minus 3. So take this decimal point after 3 digits. Rate constant is equal to 105.9 into 10 power minus 3 minute inverse. So the nearest integer for this 105.9 is 106. So the answer is 106 into 10 power minus 3 minute inverse. The reaction 2A plus B2 gives 2AB is an elementary reaction. So here elementary reaction represents single step molecular collision reaction. So what is the thing you have to note down is, for a elementary reaction we can write the rate law directly from the coefficient itself. So here the mentioned equation is 2A plus B2 gives 2AB. So rate is equal to rate constant into concentration of A power the coefficient 2 and concentration of B2, and the coefficient is 1. So here no need to mention that one. So the rate of the reaction with respect to the coefficient we have written. So rate is equal to K concentration of A power 2 then concentration of B2. So for a certain quantity of reactants, if the volume of the reaction vessel is reduced by a factor of 3, the rate of the reaction increases by a factor of dash. So here they are telling to round off the nearest integer. So they have mentioned that volume of reaction vessel is reduced by factor of 3. Then we know that volume is inversely proportional to the concentration. So therefore concentration of reaction vessel, that is the reactant, concentration of the reactant increases by a factor of 3. So we can tell that after the reduction of the volume, the new concentration of the reactant A dash is equal to 3A, and the new concentration of the reactant B2 is equal to 3B2. So B2 dash is equal to 3B2. So just we can substitute that rate is equal to rate constant. So just see this equation. Rate is equal to K into concentration of A is now 3A square. Then concentration of B2 is 3B2. So we can just take the numbers outside. 3 square is 9 and into 3. Then you write the remaining terms. K into concentration of A square into concentration of B2. So the new rate is equal to 27 into K A square concentration of B2. So the rate of the reaction increases by a factor of 27. The next question is, for the reaction 2A plus 3B plus 3 by 2C gives 3P. Which statement is correct? So here the rate of the reaction is given. So for this given equation, we can write the rate of the reaction. So I already told, for the rate of the reaction, the coefficient is also related. So the coefficient of A is 2. So A is the reactant. So it is minus 1 divided by the coefficient 2 into rate of change of the concentration with respect to time. That is equal to, then again the reactant B minus 1 by the coefficient, then rate of change of the concentration of B with respect to time. Then again we are talking about the reactant. So in this options A, B and C is only mentioned. So again minus, so here you have to see the reciprocal. So in equation the coefficient is 3 by 2. So here it should be written as 2 divided by 3, change in concentration of C by change in time. So if you see the options, everything is a positive value. So this whole equation is multiplied by minus 1. And what is the another common thing in this equation, in this option, is there is no coefficient for the term change in concentration of A with respect to time. So we have to eliminate the coefficient. So in this case, the coefficient is 1 by 2. So to eliminate the coefficient 1 by 2, you have to multiply the whole equation by 2. So already we are having minus 1. So this is again multiplied by 2. So now we will see the equation. So it will become, the negative sign will become positive and 1 by 2 will be cancelled. So D, so here concentration is represented by moles. So now I write in that way, change in the number of moles of the reactant A divided by change in time. So that is equal to, again minus will get cancelled in the other two terms also. So here we are having 1 by 3. Now 2 multiplied by 1 by 3, it is 2 by 3, change in the number of moles of the reactant B by change in time. So that is equal to, so again we are having 2 multiplied by this term, 2 into 2 by 3. So 2 into 2 will become 4. 4 by 3, change in the number of moles of the reactant C by change in time. So this is the final answer. So let us check which option is the correct option. So dNA by dt is equal to 2 by 3 dNB by dt is equal to 4 by 3 dNC by dt. So option C is the correct answer. The next question is, for the reaction 2H2 plus 2NO gives N2 plus 2H2O. The observed rate expression is, rate is equal to rate constant of the forward reaction. Here Kf represents rate constant of forward reaction. So rate equal to Kf, concentration of NO power 2 into concentration of H2. So power is not mentioned here. So the rate expression for the reverse reaction is, so first let us write the equation, 2H2 plus 2NO gives N2 plus 2H2O. So two reactions we are going to see, one is the forward reaction and the other one is the backward reaction, that is the reverse reaction. So first let us write the rate of the reaction for the forward reaction. So we can mention this as RF. So rate of the reaction for the forward reaction is, so rate constant of the forward reaction into concentration of NO, so the coefficient is 2, and concentration of H2, here the coefficient again it is 2. Now we will go to the rate constant of the reverse reaction. So it is, we can write it as RB, backward reaction. So here we are going to talk about N2 and 2H2O as the reactant, because now we are seeing the backward reaction. So we are seeing the backward reaction. So rate constant of the backward reaction into concentration of N2 into concentration of H2O, and what will be the power? So the power is the coefficient here 2. So here we are talking about equilibrium. So at equilibrium, rate of forward reaction is equal to rate of backward reaction. So we have to equate these two terms. The right hand side we have to equate. So we will see that So the right hand side we have to equate. So the rate constant of the forward reaction, concentration of NO power 2, concentration of H2 power 2 is equal to rate constant of the backward reaction, concentration of N2, concentration of H2O power 2. So you just see here we are having the term H2 power 2, but in question concentration of H2 is not having power. So it means that one of the concentration term is taken to the right hand side. So I will continue here. So the left hand side is rate constant of the forward reaction into concentration of NO square into concentration of H2, and another concentration term is taken to the right hand side, so it will go to the denominator of the right hand side. So that is equal to Kb square bracket of N2, then we are having square bracket of H2O square whole divided by concentration of H2. So this is the answer. So it is equal to, I will write it again, Kb concentration of N2 concentration of H2O square divided by concentration of H2. So in denominator we are having concentration of H2. So option A we are not having any denominator term. So option C is also ruled out. Option B is also ruled out because here the denominator is NO. So option D is the correct answer. Next question is, in the reaction XA gives YB log to the base power 10 of disappearance of A, so it is mentioned as minus change in concentration of A by change in time is equal to log to the base 10 of appearance of B. So that is represented by change in concentration of B by change in time plus 0.3010. So we know that 0.3010 is log 2. So we will keep that in mind. Now the question is A and B respectively can be. So options are given. So to find the answer, we need to know the coefficient X and Y. With that, we can find the compounds. So for that, let us take the equation as it is. XA gives YB. We can write the rate of this reaction. So the rate of disappearance of the reactant. So minus 1 by X, change in concentration of A by change in time is equal to rate of appearance of product. So 1 by Y dB divided by dt. So let us bring to the format given in question itself. In question, only minus dA by dt is given. So let us take this X to the right hand side. So minus dA by dt is equal to X by Y dB by dt. Now in question log is taken on both the sides. So let us take log on both sides. So log to the base 10 of minus dA by dt is equal to, so first dB by dt term is given. So these two terms are in multiplication. We know that log of AB is equal to log A plus log B. So log to the base 10 of change in concentration of D by change in time plus this term log of X by Y. So now if we see the equation given in question, this is same as the equation which we got now. So from this equation, from these two equations, we can come to the conclusion that the term 0.3010 can be equated to the term log of X by Y because all the other terms are the same. So already we told that 0.3010, that is nothing but log 2. So this can be equated to this term log of X by Y. So log 2 is equal to log of X by Y. So we can cancel log on both sides. So 2 is equal to X divided by Y. So taking Y to the other side, 2Y is equal to X. So in equation, it is given XA gives YB. So now in place of X, we are going to substitute 2Y. So 2Y of A gives YB. So what does this mean? If the value of Y is 1, then the coefficient of A is 2Y. So 2Y is 2. So if we see these options, only for option C, we can write such equation. So if you take option C, we can write C2H4 gives C4H8. So if you balance this equation by equating the number of carbon and number of hydrogen atoms, obviously it is 2C2H4 gives C4H8. So only for option C we are getting the correct coefficient. If we see the other reactions, so let us check that. So in the option D, N2O4 gives NO2 is given. So if you balance this equation, you have to write the coefficient 2 in the product side. But here the reactant is twice the amount of product. So option D is having product as 2NO2. So option D is wrong. Then if you go to option B, C2H2 gives C6H6. So if you balance this equation, number of carbon atoms in product is 6, but in reactant it is 2. So here you have to write 3. So it is not twice, it is thrice the number of moles of product. So option B is also wrong. So if you go to option A, they are telling N-butane is converted to isobutane. So it is just the isomerism. That is, the structural arrangement alone differs. The molecular formula C4H10 is same. So C4H10, and for the isobutane also the molecular formula is C4H10. But here the structural arrangement is different. For N-butane, the arrangement is straight chain. CH3, CH2, CH2, CH3. So it is converted to its isomeric form, isobutane, CH3, CH, and methyl group is branched. Then it is CH3. So option A is also wrong. So option C is the correct answer. Next question is, NO2 required for a reaction is produced by decomposition of N2O5 in CCl4 as per the equation. So the initial concentration of N2O5 is 3 moles per liter and it is 2.75 moles per liter after 30 minutes. So the rate of formation of NO2 is, so already we saw this question. So in this question number 21, we already solved this question. So it is the same pattern. So a equation is given. So we can write the rate of the reaction. For the reactant, it is minus 1 by 2 d N2O5 by dt. That is equal to the product we are talking about as NO2. So 1 by 4 d NO2 by dt. So we need to find the rate of formation of NO2. So you have to find this term. So we will rearrange this equation. So d NO2 by dt by taking this 4 to the left hand side. So that is equal to 4 divided by 2. So minus is there. Then change in concentration of N2O5 by change in time. So in question, change in concentration of N2O5 is given. So change in concentration of N2O5 is equal to final concentration minus the initial concentration. 2.75 minus 3. So that is 0.25. 0.25 moles per liter inverse. And the time is mentioned as 30 minutes. So the change in time dt is equal to 30 minutes. So here 2.75 minus 3, it is minus 0.25. So already we are having a minus here. So minus 4 by 2 will become 2 into, here you are having minus 0.25 as the change in concentration of N2O5 divided by 30. So here you will get the answer as 0.0166. So this is the answer, moles, liter inverse, minute inverse. So if you check the answer in option B, you are having that exact number, but here the decimal point is after 2 digits. So 1.66 into, so we are moving it after 2 digits. So into 10 power minus 2 moles, liter inverse, minute inverse. So option B is the correct answer. Next question is, for a reaction scheme, A gives B gives C. If the rate of formation of B is said to be 0, then the concentration of B is given by. So this question also we already saw. So in question number 20, we already saw this answer. So for the reaction A gives B gives C, we can write the rate of formation of B from A. So the rate of formation of B is change in the concentration of B divided by change in time. So for this equation, we can write the rate law. So for the first reaction A gives B, so the first rate R1 is equal to first rate constant K1 into concentration of A. So here it is the rate of formation of B. Then the element B, that is the compound B, is consumed to give C. So here we are writing the rate for the consumption of B. So the second rate R2 is equal to, here it is acting as a reactant. So minus K2 into concentration of B. So why minus is mentioned here? Here it is, the concentration is decreased. So there is a decrease in concentration. So we are representing the negative sign. So how the change in the concentration of the compound B happens? By the rate of formation and by the rate of consumption. So now the change in the concentration of B, we can equate that with the rate of formation minus the rate of consumption. Here the negative sign is there because there is a decrease in concentration. So as it is mentioned in question, the rate of formation of B is said to be 0. So the left hand side we are going to set it as 0. Then it is equated with the right hand side, K1 into concentration of A, then minus K2 into concentration of B. I hope you understood how concentration of A came in this equation, because in rate law we are going to talk about the concentration of the reactant. So in first reaction the reactant is A, then the second reaction the reactant is B. So then that is equal to K2 minus concentration of B. So taking that to the other side and then solving, you will get the concentration of B as K1 divided by K2 into concentration of A. So the same question is asked again in 2019. So it was repeated in 2024 also. So the answer is option D. The next question is, for an elementary chemical reaction, A2 gives 2A, the expression for change in concentration of A by change in time. So the given reaction is A2 gives 2A. Here both the forward reaction and the reverse reaction takes place. So how we will write the rate of formation of A? So the rate of formation of A, that is the product A is having the coefficient 2. So when we write the rate of the reaction with respect to the product A, the coefficient should also be mentioned. So the rate of the reaction is 1 by 2 dA by dt. So we have to find the value of this. So for this reaction, A2 gives 2A. For the forward reaction, we can write the rate of the reaction using the rate law. So it is K1 into the concentration of the reactant, that is concentration of A2. Then for the reverse reaction, we can write the rate law R2 is equal to, so the rate constant for the reverse reaction we are going to write as K minus 1 into, now the reactant is A, 2A. So as it is an elementary reaction, concentration of A power 2. So now how these two rate laws are related to the change in concentration of A? So the forward reaction tells the formation of A. So here we are having the rate of formation of A. Then the reverse reaction tells the rate of consumption of A, because here A becomes the reactant. So the reverse reaction tells the rate of consumption of A. So this is how the concentration of A changes. So the concentration of A is related to these two rate laws. So for that, let us first take this 2 to the right hand side. So I will erase that in the left hand side. So we are taking 2 to the right hand side. 2 into rate of formation. First the A is formed, then only it undergoes consumption. So rate of formation of A minus rate of consumption. So this is how there is a net change in the concentration of A. So it is 2 into K1. So R1 is K1 into concentration of A2 minus K minus 1 into concentration of A square. So when you multiply this 2 inside these two terms, so the final answer is 2K1 concentration of A2 minus 2K minus 1 concentration of A square. So the correct answer is option D. The next question is, the reaction of ozone with oxygen atoms in the presence of chlorine atoms can occur by a two-step process shown below. So two equations are given with their rate constant. the closest constant for the overall reaction. So the overall reaction is also given. So the overall reaction we can get from adding the first and second equation. So the first equation is O3 plus Cl dot chlorine free radical gives O2 plus ClO dot. Then second equation is ClO dot plus O dot gives O2 plus Cl dot. So you have to add these two equations. So chlorine free radical in reactant side in first equation and it is in product side in the second equation. So we can cancel that. Then ClO free radical in product side in first equation and it is in reactant side in the second equation. So we can cancel that. So the remaining terms are O3 plus oxygen free radical gives. So O2 is in the product side. In both the equations, O2 is in the product side. So you have to add that. So it is 2O2. So it is the same overall reaction given in question. So the overall reaction we can get by adding the first and second equation. Now we have to find the rate constant for the overall reaction. So the rate constant for the overall reaction is equal to the rate constant of the first equation multiplied by rate constant of the second equation. So the rate constant of first equation is 5.2 into 10 power 9 into rate constant of second equation 2.6 into 10 power 10. So when you multiply the numbers, you will get 13.52 into, when you multiply the power, you will get 10 power 19. So let us take one decimal place backward. So 1.352 into 10 power 20. So the closest constant they are asking. So we can round off this value. 1.352 is 1.4 into 10 power 20. So the correct option is option A, 1.4 into 10 power 20 liter mole inverse second inverse. Next question is, the rate law for the reaction below is given by the expression K, concentration of A and concentration of B. For the equation A plus B gives product. If the concentration of B is increased from 0.1 to 0.3 moles, keeping the value of A at 0.1 mole. So concentration of A is same and concentration of B is increased. The rate constant will be. So here they are asking what will happen to the rate constant if the concentration of B is increased. So rate constant is independent of concentration of the reactants. So when we change the concentration of the reactants, the rate of the reaction will increase or it will change. The rate of the reaction changes, but the rate constant is independent of the concentration. So the rate constant value is mentioned as K. So it will remain as K. There is no change in the rate constant. Next question is, A plus 2B gives C. The rate equation for this reaction is given as rate equal to rate constant into concentration of A into concentration of B. If the concentration of A is kept the same, but the concentration of B is doubled, what will happen to the rate itself? So it is a very simple question. So the initial rate given in question is K into concentration of A, concentration of B. Then the rate when concentration of B is doubled, so B dash is equal to 2B. So it is concentration of A is kept constant, then concentration of B dash. So that is K into concentration of A, then B dash value is 2B. So 2B. So that is equal to 2. We have to take the 2 outside. So 2 into rate constant A into concentration of B. So R2 is equal to 2 into R1. So what will happen to the rate itself? The rate is doubled. So correct answer is option C. The next question is, for the non-stoichiometric reaction, 2A plus B gives C plus D. The following kinetic data were obtained in 3 separate experiments, all at 298 Kelvin. The rate law for the formation of C is. So we need to find the rate of the reaction. So we can write the rate law for the given equation. 2a plus b gives c plus d. So we can write the rate of the reaction for this equation. So rate equal to rate constant into concentration of the reactant A power x and concentration of the reactant B power y. X is the order of the reactant A and y is the order of the reaction with respect to the reactant B. We don't know x and y. So we have to find that using this table. So here the rate refers to the rate of appearance of C, dC by dt. So we need to find that. So first we can take the first row and the second row and we can substitute the values. So the equation is rate equal to is given. So I will erase this. So the first row is having the rate value as 1.2 into 10 power minus 3. That is equal to rate constant into concentration of A is 0.1 power x and concentration of B is also 0.1 power y. Then going to the second row. So this is the first equation. Then the second equation is again the rate is 1.2 into 10 power minus 3. That is equal to rate constant K. Then concentration of A is again it is 0.1 whole power x. Then concentration of B is changed now. So it is 0.2 the whole power y. So now we are going to divide the first equation by the second equation. So the left hand side is 1.2 into 10 power minus 3 divided by 1.2 into 10 power minus 3. That is equal to K will get cancelled. So I will just write that K into 0.1 whole power x is 0.1 whole power y divided by K into 0.1 whole power x is 0.2 whole power y. So K and 0.1 whole power x will get cancelled. Then left hand side also is cancelled. So you will get 1 is equal to 0.1 by 0.2. So that we can write as 1 by 2. 1 by 2 the whole power y. So now I have to find the power y. So in left hand side I am having 1. So already the base is different. Now if the power is equal to 0, so anything power 0 will become 1. So 1 equal to 1 by 2 power 0. 1 by 2 power 0 is nothing but 1. So in this case the base is different. So the left hand side is 1. I have to make this term as 1. So anything power 0 is only equal to 1. So the value of y is 0. So now let us see the third equation. So let us compare first equation and third equation. So already we have written the first equation. 1.2 into 10 power minus 3 is equal to K into 0.1 whole power x, 0.1 whole power y. Then third equation is rate constant is given as 2.4 into 10 power minus 3 is equal to K into the concentration of A is changed now 0.2 whole power x. Then concentration of B is same 0.1 whole power y. So when you divide 1 by 3, so you will get as 1.2 into 10 power minus 3 is divided by 2.4 into 10 power minus 3. So that is equal to K into 0.1 x whole power x, 0.1 whole power y divided by K into 0.2 whole power x, 0.1 whole power y. So when you cancel rate constant and 0.1 whole power y, we can cancel. And now if you see the left hand side, 10 power minus 3 is cancelled. Then 1.2 by 2.4 is 12 by 24. So 12 by 24 is equal to 0.1 by 0.2. It is 1 by 2. 1 by 2 whole power x. So the left hand side is also 1 by 2. When you cancel 12 by 24, you will get 1 by 2. So the left hand side is 1 by 2 whole power 1 is equal to 1 by 2 whole power x. So now the base is same. So the base is same. So the powers are also equated. So x is equal to the power 1. So the value of x is 1, value of y is 0. Now let us rewrite the rate law. Rate is equal to rate constant into a power 1. So and it is equal to into b power 0. So the order of the reaction is first order with respect to a and 0 order with respect to b. So anything power 0 is 1. So this is equal to K A, concentration of A. So the correct option is option D. In the reaction of formation of sulfur trioxide by contact process, 2SO2 plus O2 gives 2SO3. The rate of reaction was measured as, so the equation given is 2SO2 plus O2 gives 2SO3. So the rate of the reaction with respect to the reactants, so the rate is equal to minus the coefficient of SO2 is 2. So 1 by 2 dSO2 divided by dt, that is equal to minus dO2 by dt. So the value of dO2 by dt is given as minus 2.5 into 10 power minus 4 mole liter inverse second inverse. The rate of reaction in terms of SO2 will be, so they are asking us to find dSO2 by dt. So just take this 2 to the right hand side. So you will get dSO2 by dt is equal to, you are having a minus sign here, 2 minus 2 dO2 by dt. So that is equal to minus 2 into value of dO2 by dt is given as minus 2.5 into 10 power minus 4. So that is equal to 2 into 2.5 is 5 and minus will get cancelled. So it is 5 into 10 power minus 4. But already we are having a negative sign in the left hand side. So it is minus 5 into 10 power minus 4. So in option itself negative sign is given, because in left hand side also we are having one negative sign. So it is minus 5 into 10 power minus 4. For the reaction 2N2O5 gives 4NO2 plus O2. The rate equation can be expressed in two ways. So first we will write the equation 2N2O5 gives 4NO2 plus O2. So minus dN2O5 by dt is written as K into concentration of N2O5 and dNO2 by dt is written as K dash into concentration of N2O5. K and K dash are related as. So in this equation we are talking about N2O5 and NO2. So let us write the rate of the reaction with respect to these two compounds. So for the reactant it is minus 1 by 2 dN2O5 by dt, that is equal to, product side we are having NO2, so it is 1 by 4 dNO2 by dt. So now in question dN2O5 by dt can be written as what? K into N2O5. So let us substitute the value. So for this term we are going to write K N2O5, that is equal to 1 by 4 dNO2 by dt can be written as this term. So 1 by 4 into K dash into concentration of N2O5. So we can cancel concentration of N2O5 and the negative sign also is included in this KN2O5. So here no need to write the negative sign. So the concentration of N2O5 is cancelled on both the sides. So then we are having K by 2 is equal to K dash by 4. So K is equal to, when you cancel this you will get K dash by 2. So take this 2 to the left hand side. 2K is equal to K dash. So the correct option is option B, 2K equal to K dash. For the reaction 3A plus 2B, 3A plus 2B gives C plus D. The differential rate law can be written as. So options are given. So the options include the differential rate law with respect to A and C. A is the reactant and C is the product. So from the given equation we can write for the reactant minus 1 by 3 dA by dt, that is equal to dC by dt. So this is the rate of the reaction with respect to A and C. Then this can be equated using the rate law to the rate constant and concentration of the reactants. So concentration of A power order. So in all the options the power is given as N. So the order of the reaction with respect to A is N into concentration of B power, it is given as M. So if you see the options, the correct option minus 1 by 3 dA by dt is in option D only. So the correct option is option D. The instantaneous disappearance of MnO4 minus ion in the following reaction is 4.56 into 10 power minus 3 molar second inverse. So the given equation is 2MnO4 minus plus 10I minus plus 16H plus gives 2Mn2 plus 5I2 plus 8H2. So the equation is given. The question is rate of appearance of I2 is. So we are talking about MnO4 minus and I2. So we can write the rate of the reaction for the given equation. So for the reactant MnO4 minus, it is minus 1 by 2 d MnO4 minus by dt. That is equal to the rate of the reaction with respect to I2 is 1 by 5 dI2 by dt. So we have to find dI2 by dt. So dI2 divided by dt is equal to, take this 5 to the left hand side, to the other side. So minus 5 by 2 d MnO4 minus by dt. So in question, the disappearance of MnO4 minus value is already mentioned. So minus d MnO4 minus by dt value is mentioned. So 5 by 2 into 4.56 into 10 power minus 3. So when you solve this, 5 into 4.56 into 10 power minus 3 is 22.8. When you multiply these numbers, you will get 22.8 into 10 power minus 3 divided by 2. So when you divide it, you will get 11.4 into 10 power minus 3 molar second inverse. So 10 power minus 3 is mentioned in option C, but here the number is 1.14, but the number we got is 11.4. So now in other option, we are having 1.14 into 10 power minus 2. So take the decimal point backward before one digit. So it becomes 1.14 into 10 power minus 2 molar second inverse. So the correct option is option B. Reaction rate between two substances A and B is expressed as following. Rate is equal to K A power N B power M. If the concentration of A is doubled and concentration of B is made half of initial concentration. So we will write the new rate R dash. R dash is equal to rate constant is same. Concentration of A is doubled. So 2A power N. And concentration of B is made half. So B by 2 power M. So the ratio of the new rate to the earlier rate. So the earlier rate is the initial rate, that is R. So the new rate R dash is equal to, so we will take the 2 power N outside. 2 power N divided by, here you will be getting 2 power M. K A power N B power M. So we can rewrite this as R dash is equal to 2 power, when you take this 2 power M to the numerator, it will become 2 power N minus M K A power N B power M. So the ratio of new rate to the earlier rate. So this is the new rate divided by the earlier rate R. So it is equal to, so the earlier rate is K A power N B power M. So everything will get cancelled. So R dash by R is equal to 2 power N minus M. So the correct option is option D. Consider the reaction Cl2 plus H2S gives S plus 2H plus 2Cl minus. The rate equation for this reaction is rate equal to K concentration of Cl2 into concentration of H2S. Which of these mechanisms is or are consistent with this rate equation? So already the rate equation for this reaction is given. Here mechanism for this reaction is mentioned. Mechanism A and mechanism B. Now we are going to write the rate equation for the mechanism and we are going to check which of the mechanism is consistent with this rate equation. So always the slow step is the rate determining step. So we have to write the rate equation for the slow step only. So for the mechanism A, the slow step is first equation. So the rate of the reaction is equal to rate constant into, the reactants are Cl2 and H2S. So concentration of Cl2 into concentration of H2S. So this is inconsistent with the rate given in question. So mechanism A is correct. Now we will check the mechanism B. So for mechanism B, the slow step is the second equation. So the rate of the reaction is equal to rate constant into concentration of Cl2 into concentration of Hs minus. Here instead of H2S, Hs minus is given. but we have to find the rate of the reaction with respect to H2S only. So you see the first equation of this mechanism B. So I will write here. The first equation is a chemical equilibrium reaction. H2S is in equilibrium with H plus HS minus. So for this reaction, we can write the equilibrium constant. So the equilibrium constant for this reaction is concentration of the product divided by the concentration of the reactant. So we are having this term, no, concentration of HS minus. So we are going to find the value of this concentration of HS minus. So take this H2S and H plus to the left hand side. So the concentration of HS minus is equal to Kc into concentration of H2S divided by concentration of H plus. Now we are going to substitute this value of Hs in this equation. So the rate of the reaction is equal to K concentration of Cl2. So and instead of Hs minus, we are going to substitute this value Kc concentration of H2S divided by concentration of H plus. So already we are having one rate constant and then another equilibrium constant is there. So both multiplied together will give a new constant, new rate constant. Rate is equal to K dash into concentration of Cl2, concentration of H2S divided by concentration of H plus is also there. So in first mechanism, it is consistent with the rate law given in question. But for the second mechanism, concentration of H plus is also mentioned. So it is not consistent with the rate law given in question. So which of this mechanism is consistent? Only the first mechanism is consistent. So the correct option is only A only. So option D is the correct answer. For a reaction, 1/2A gives 2B. Rate of disappearance of A is related to the rate of appearance of B by the expression. So for the given reaction, we can write the rate of the reaction. So already the coefficient is 1/2. So in rate of the reaction expression, it will become minus 2 into change in concentration of A by change in time. That is equal to 1/2 dB by dt. So if you see the options, only minus dA by dt is in the left hand side. So take this 2 to the right hand side. So you will get minus dA by dt is equal to, when you take the 2 to the right hand side, it will become 1/4 dB by dt. So this is the answer. So the correct option is option B.